Okay, do you guys see my screen now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Uh, Here we go. We were talking about I think I have already done with these things. We were talking about this Entre programming utilities, right? E-utilities. This is the slide I think we have stopped last time in our previous lecture, right? So, are you aware of this term Entre? ENTREZ correspond to Entre. Okay. Have you guys heard this term before?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay,
Yes,
so,
sir.
so
But
this
not aware actually.
okay, Entree is, you can say, a search engine developed to search different databases that are present on this NCBI resource. Okay, that we call it as Entree, and it is due to this Entree you have got similar features lying around all over the databases that are hosted on NCBI or tools that are hosted on NCBI. Okay, so just like Google is for searching the entire web, in a similar way your Entree is designed for searching specifically on NCBI. Okay, and you have got this section called as Entree programming utilities, what we call it as e-utilities. Well, that is generally used for automating the query to the databases. If you want to perform some automated query. So, well, say for example, if you want to know, okay, if some research papers are published in, say, some field, right, at regular intervals. Okay, what I mean to say is, what if I want to find out if articles on cancer angiogenesis are published in, well, say for example, in every week or so. Okay, how many articles are published on the topic cancer angiogenesis every week? So every week you would need to then query this database. Otherwise, what you can do is that you can write a computer script. Okay, and this can be in form of any programming language, any computer program. Okay, and this computer program would run itself at the time interval of, say, 1 week, and give you the results in a text file or something like that. Okay, so this is called as automating the querying to the database. Okay, so these e-utilities facility e-utilities not only allows you to locating the literature, but also using those e-utilities you can also somehow associate, or you can also figure out what kind of biomedical data is associated with it. Well, say for example, if there is an abstract in PubMed that links to, say, some receptor or, say, some protein, right? Then if it is related to, say, some protein, it might be associated with, say, some nucleotide gene sequence. It might be associated with protein sequence. That abstract might be associated with, say, some gene record. Or if the paper is published for, say, the crystal structure of, say some protein, then a PDB ID or PDB identifier that signifies a PDB model stored somewhere else in a PDB database can be associated with that paper. So by using this Entree programming utilities and using your programming skills, what you can do is that you can find what other stuff are associated with the same abstract that you're dealing with. Okay, but for using this Entree programming utilities, you might require some higher level of programming skills. Okay, and your NCBI's PubMed Well, of course, it support queries that are written in languages like Perl, Python, Java, and C++. So people usually do these things. Well, say for example, like automating the querying to the database when they work on, say, some big projects that involve a lot of text-based mining. Okay, so I have just given you an example of this cancer angiogenesis. Okay, you can perform very complex queries very regularly using the e-utilities tools that are available over there. All you need to do is to write some efficient programs that would fetch the desired data for you at well, say for example some specific time interval. Okay, or however you wish that data could be. Okay, so that was all about your Entree programming utilities. Then next you have something called as the mesh database. Okay, so this mesh stand for medical subject heading. Okay, so now this mesh, you can define mesh as the National Library of Medicine's controlled vocabulary thesaurus. Okay, so this thesaurus word means well, a group of words that are synonymous to each other and that are related in concept with each other. So we can list out such words in thesauruses as such. Okay, so now one might ask over here ki, why do we need such list of related synonymous word to be listed specifically in PubMed? So what purpose would it serve now? So in order to answer that, well, just consider this scenario ki there is a researcher who is working on vitamin C. Okay, and he want to find out how many research papers are published on vitamin C in, say, some duration, or C or say for example how many labs or how many authors have published paper on vitamin C, so on and so forth. The thing is ki this vitamin C is alternatively also known as ascorbic acid, right? So the person who is interested in finding out literature on vitamin C would eventually also be interested in finding out the articles that describe the same vitamin C but in different word. Now in our case it would be ascorbic acid, right? So in this way, by connecting these synonymous word in this database called as mesh, if someone seeks out an article that describes vitamin C, since these words are interrelated to each other in this mesh database, he won't miss out the same concept if the same concept is described in terms of some another words, we'll say for example ascorbic acid, right? So this is a very interesting feature that allows you to perform very powerful searches. Okay, another example I would like to cite is that if a person is interested in cancer, he or she shall also be interested in topics like tumor or neoplasia, right? Because cancer is usually associated with tumor, it is also called as neoplasia. Therefore when you have such closely related or synonymous words coupled to each other, the user would be able to fetch out those articles which do not have per se the specific words but have specific meaning in similar. Okay, so this is what is the main objective of having this mesh database in implemented in your PubMed. Okay, so using this mesh terms would ensure what you can say full coverage of concepts in your search results. Okay. Next, I would just give you a more brief detail of this mesh database. So this database consists of a set of terms, and these terms in mesh are called as descriptor. So technically speaking, when you say that you are searching in mesh, you are searching for descriptors. Okay, in fact, you would be searching for medical terms, but mesh people, those developer, called those medical terms as descriptors. Okay, and now these descriptors are arranged in hierarchical structure or simply tree structure. And due to this arrangement in hierarchical or tree structuring would permit the user for searching at various levels of specificity. Okay, so well, say for example, to make my point clear, now consider the right hand side of this slide. You can see over here that we have tried to arrange these medical subject headings or mesh terms or mesh descriptors into this tree structure as shown over here. As you can see, you have got this digestive system diseases, which in turn can be classified into either having gastrointestinal diseases or digestive system neoplasm. These gastrointestinal diseases, there are various components of your gastrointestinal tract, right? There is stomach, there is esophagus, right? There are intestine. So then you can again increase your specificity to stomach for to go in more details rather than searching into more broader terms like gastrointestinal disease. One can specifically search for stomach diseases as well. Okay, on the other hand, we have clubbed this concept with another concept of cancer, that is neoplasm. So this neoplasm can be neoplasm by site. This site can be this site can be in digestive system. Therefore the neoplasm occurring in digestive system can be termed as digestive system neoplasm. Okay, this specifically digestive system neoplasm might also refer to gastrointestinal neoplasm, and eventually to go into more specific way you can have stomach related neoplasm. In this way, by arranging the terms, or you can say synonymous term, in an hierarchical manner, what you can do is that you can allow the user to permit search as various levels of specificities as such. Okay, so you can have or you can allow searching in PubMed at a broader sense, as well as you can allow the searches to happen on very specific specific scale as such. Okay, so in this way these mesh descriptors are arranged in both alphabetic as well as hierarchical structure. Okay, so far back in 2016 I haven't changed this number so far. Well, for sure we know that there are at least 27,000 or so descriptors in your mesh database, and these descriptors can have 87,000 entry terms in them. Okay, so this is what your mesh database is all about. Okay, so now using this mesh tree structure, this utility would allow to find relevant mesh terms and the corresponding associated articles associated with those mesh terms. So the user would be able to find such articles that are relevant to those mesh terms if only some general concept is known to that search, okay, or that researcher. Okay, so using this mesh term, if you only know the general concept, still you would be able to figure out the articles associated with that general concept as such. Okay, so when you are using this mesh tree structure, that would of course lead you to be more specific and hence increase the precision of your searching, right? And in this way your resource would be able to maintain the right balance between precision of the search results as well as the time required to conduct that query. Okay, so using this mesh term would also gives you an advantage that it would allow to broaden the search domain. Okay, so and due to broadening of your search domain, you would be able to fetch out the related article as well, right? So if you search for stomach cancer, somehow you would also get articles related to other gastrointestinal disorders or cancers as such, right? So that would give you a kind of freedom to have a broad search domain as well, right? The next thing that is important, is that you are able to connect two concepts with each other. Okay, so you can say it is a convenient means of grouping together citations which are concerned with a particular aspect of a subject. Okay, well, say for example, the drugs are usually metabolized by liver enzymes, right? So now using this interconnected mesh terms, you can easily find out those articles that describe what is the effect of drug on liver, or how they are excreted, or how they are further metabolized, right? So this become a convenient way of doing such an analysis. Okay, so these are all advantages of having this mesh database, or the interconnected network of mesh terms to be associated with your PubMed. Okay, so this is all. Okay, we have already come across to this slide. Well, now we would move on to our next topic. Okay, now we would start out with searching. Okay, now can you guys see my screen? मेरी स्क्रीन दिख रही सब लोगों को?
Yes, sir.
Yes.
Okay, now we would begin. I would just give you a few tips on how do you search in PubMed, right? So in my previous lecture, or whatever we were talking about, I was just trying to give you some theoretical details of what are the different concepts that are normally used in PubMed, so that you would have a proper understanding on what kind of search result do you get. Okay, so this is what I am going to talk about in this presentation. So we would see how do you search by concept, then how do you search by author names. You can also search by journal name, and how do you do that? How do you search this database or this PubMed resource by date? What are the different type of dates by which you can search PubMed? Then we would talk about Boolean operators and how you can use them. So these are just very basic queries that you can perform using this PubMed. Then I would also brief you on how do you interpret your search result, what are the ways in which you can display and sort your search result, and eventually from where do you obtain the full text of your article if you are interested in, say, some articles as such. Okay, and we would also talk on how do you save the search result, and finally I will give you some very important field descriptions and tags that you can use for efficient searching. Okay, so let us start. I think we would cover it up in an hour. So first, let us start talking on the searching the PubMed by concept. Okay, so when you go on searching in any database, or you go on searching on any search engine, what you usually do is that you put some keywords and hit the search button and let the search engine do its job. Okay, but that would also lead you to get a lot of unwanted, or you can say VD result, that you need to sort it out before you know, kind of specifically locate, okay, this is what I am interested in. So if you perform the search by giving a proper keyword or by proper concept that this database might interpret quite well, then that would decrease the amount of hits or number of hits that you usually end up when you just give a random set of words for searching. Okay, so what you need to do is that if you want to search this PubMed as a resource using some using some concept, then you need to identify what are the key concepts in your search. Okay, now what you need to do is that you should enter the term or key concept in the search box and click search as what you usually do. Well, I would just give you an example. If you have a concept in mind, or if you have a question in mind about what role does pain have in sleep disorder, so you cannot directly go on searching like what role does pain have in sleep disorder in your PubMed, and you might get you know say some very irrelevant result. That is not the correct way of searching any database, or that is not the correct way of searching, in fact, in any search engine. So if you have any concept in mind, you should first try to conceptualize key what are the main concepts that you are searching for. So in our example, the main concept would be, I would like to have articles that describe pain and sleep disorders. Okay, so using these two key concepts, you can get out all relevant research articles. Okay, that would somehow decrease the the bulk of the results that you get, and you can thus save yourself from weeding out the unwanted search results that you usually get. Okay, so so defining the concept of your search is very important. Okay, so next thing is that you can search by author names. Okay, so well, say for example, to search by author name, all you need to do is that you can search the PubMed in a specific format, followed by surname followed by initial. Well, say for example, you can search my articles, like how many research articles I have published in PubMed. If you want to do such search, you can just put my initial my surname Meshram, and then my initial RJ, and hit the search result. You would get some hits. Okay, so now what if the author's last name is entered? If only the author's last name is entered, okay, tag the name with author search field. So the thing is that whenever you search in PubMed, what you can do is that you can provide a tag to your concepts. Okay, well, say for example, when you search by author and you search by surname, okay, then when you put this surname spelling over here, and if you tag it with this tag AU, that would mean that you are asking PubMed to search in a field called as authors. So it won't search in mesh database or say some other irrelevant locations. Okay, so that would increase your search results to be more specific. Okay, say for example, if you search like gache and you give a tag AU, okay, so your PubMed would search only in a field of authors list and sort out if there are articles that are authored by this person or this researcher Gache as a surname. Okay, so alternative, you have other tags available like 1AU. This 1AU would allow you to search for that author at the first position in the list. Or last AU, using this tag, would enable you to search that author to be located at the final position. Okay, say for example, if you want to search that how many articles are published by Urmila Kulkarni Kale as a first author, then you would like to search it like Kulkarni Kale U and then give a tag 1AU. So such a query would search the database having the author name Kulkarni Kale U, and it should be present at the first position. Okay, if you want to search that how many articles are published by this author Deobakar DD at the corresponding author's position, then you would search it with the tag of last AU, right? So now it is also possible after 2002 as such you can also search this PubMed by a full author's name. Like if you want to search how many articles are published by researcher Manali Joshi, then you can put a tag FAU. Okay, so FAU would stand for full author names. Okay, so this Manali Joshi, if you search it using a tag FAU, so it would indicate that PubMed to search for full author name, right? Or you can alternative also search as Joshi Manali for full author name. You might get the similar results. Okay, so I have told you how do you search by author's surname. You can also search according to the author's list whether the author is present in first position or last position, or if you somehow want to search by the author's full name, you can also do that. Okay, so these are called as tags, and tags are useful for narrowing down the search result or narrowing down your searching to a specific field rather than searching in all of the fields in the database as such. Okay, good. Now there are some conventions that are usually followed when you search by author's name. Okay, so usually a comma following the last name of search is optional. Okay, so it is better if you provide a comma after the last name so that your search engine or your Antre would know ki whatever present behind this comma is the surname, and whatever present after the comma are the initials. Okay, now if you search by Desai, comma Dattatreya V, then the search engine would know ki you are searching for an article published by a researcher whose surname is Desai and his first name is Dattatreya and middle name starts with V. Okay, so now what might be the reason of having this convention? Okay, so to clear it out, what about Chinese names? Well, the Chinese names are very confusing. So okay, in such a case, since we are Indian, we know that Desai is a surname and Dattatreya V is initials. Okay, the name of the researcher and V might be its middle name, right? So since we are Indian, we can perceive this thing. But what if people who are not familiar with Indian names? Similarly, we are not familiar with Chinese names. So it becomes difficult for people to have that perspective. Therefore, giving a comma after surname becomes a very handy thing. But that thing is optional now. Okay, so in case of Chinese, if you search for an article, if you search PubMed using an author name Wu Zhu, so how would you think that your PubMed would interpret this search? Okay, it would of course search WU, that is Wu, in surname and XU in initials. Okay, so this search can be made more clear by putting a comma over here. Okay, this would search for WU as surname and XU as initial. Okay, and if you search XU comma WU, you can search for XU as a surname and WU as initial. So this becomes handy in order to determine okay, what was the surname or what was the initials. Okay, the next thing that you should know is that there is no need of putting that periods after the initials. Okay, or you can say if there is no need to put that period or full stop after the suffixes at the end that is usually provided. Well, so for example, if you want to find out articles that are published by Robert Downey Jr., then it is not necessary to put a period or full stop after junior. Try doing this search for Robert Downey Jr. if you see any article published by Iron Man. Okay. So this is just for you to know what do this stand for, right? Okay. Now you can also search by journal title. Okay. You can either search by full journal title, or you can will say, for example, articles published in archives of biochemistry and biophysics. You can also search by abbreviations, like archives of biochemistry and biophysics can be abbreviated as arc biochem biophys. Okay, you can also search by ISSN number. Okay, so in this way, by journal title, and you can combine it with author name, so that you can figure out how many articles of author Meshra Marji are published in journal archives of biochemistry and biophysics. So you can also perform or twist and tweak your search terms as per your requirement. Okay, so next important thing that you would learn is that wouldn't it be cool if you are allowed to search it by date? Okay, so most probably you would be resulted in the latest literature if you are writing a research article, or if you are writing a review article, right? So while you write a research article or while you write a review article, you would be interested in discussing something that has happened recently rather than something that happened back in 1946, right? So using, or you can querying this querying this PubMed database by date would enable you to do that thing. Okay, so if you want to search by dates, you can use the format like, first you would have to tell the year, then month, and then date, and provide the date fields. Now there are different date fields that I am going to explain you just after a while. Okay, so different date fields that are available for searching PubMeds are date of publication, which can be inferred using this tag DP. Okay, so if you put some date and give a tag DP while searching, that would mean you are searching this PubMed to include both you say articles that are printed in printed format as well as electronic date of publication, right? Now you can search for a single date does not include items when electronic date of publication is after print date. Well, now dekho, the thing is that there can be a time lag when the article is published online, public accepted for publication, and when it gets printed and published further on, right? So what I mean to say is once the article get accepted, what journals can do is that they can make it available right away as published, what you can say, uh, I just lost a phrase for that thing. You can say articles published ahead of date, you can say, right? So it is possible that even though the article is not printed, but since it is accepted, the article has undergone all the peer review, it can be made publicly available before it has been published. So we call it such as electronic date of publication. Such articles may not be printed in say some issues yet. Okay, so you can have a tag like EPDAT that correspond to electronic date of publication in such cases. Okay, it is accepted, but it is published ahead of printing, you can say. It is not printed yet, but it is available for researchers. So you can search using such electronic date of publication. You can also search when the article was printed, like you can have this PP tag involved in it, so that you can search it by date of publication, or what we can say print date of publication. Then you can also search using this tag EDAT that correspond to Antre date. This is the tag that would enable you to identify or search the date the citation first appeared in PubMed. Okay, you can also search using MHDA. This tag is useful for identifying the mesh date, that is the date the citation was indexed in mesh terms. Or you can also search using the tag CRDT that correspond to the date the citation was first created in PubMed. Okay, so the thing is that if you don't know the month and date, that is also workable, because so far you know the year, you can somehow perform the searches as well. So the month and day are optional over here. Just a minute. Hello. Hold on. Okay. 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 So this month and day are optional in case of date searches as such. Okay. Now you can also enter search your PubMed using the range of dates. Okay. So how many articles are published between 2016 and 2020? तो इसके लिए आपको कोलन देना पड़ेगा. You would have to put a colon between the date followed by the date field. Like we'll say, for example, how many articles are published between year 1993 and 1995. You can construct such a query for this, or some the other way around. If you know the month and year, okay, or the date of creation, you can have such a query. Okay, so now such comprehensive searches for full year should be entered as in double date format, rather than only 2000 and date of publication. That would make really less sense. Okay, so that is what is all about your searching by date. Okay, now there is another concept called as Boolean searching. You might be already aware of these things. Okay, so I would not go in more details of that. So this PubMed applies an AND operator between the two concepts while searching by default, and AND operator is always used. Okay, so we'll say, for example, if you search for vitamin C and common cold, so this phrase without quote, okay, I'm telling that if you search vitamin C and common cold without quote, without this quote, this query would be translated as search the database with the two terms vitamin C and common cold. Okay, so by default and would be used to connect the phrases, or to connect the terms in your queries as such. Okay, so now these Boolean operators are to be entered always in an uppercase. Okay, or you can combine them in an order. Okay, so we'll say, for example, and would retrieve search result that include all of the search terms that you are using to join these two terms, these or whatever number of terms. Okay, you can use or to retrieve results that include either one of the terms. Okay, and not would exclude the retrieval of certain terms from your search. Okay, so these are the three usually used Boolean operator for constructing effective queries. Next, this is how you can use the Boolean operators. So if you want to find citations on DNA that were authored by Dr. Crick in 1993, this is how the search term would be. You would search for DNA in mesh terms. You would end it with crick, and you would specify by giving a tag that this crick term is to be searched in author. And you would also have to find out all those terms that were published in 1993 by giving the tag of date of publication. Okay, so this is the perfect way of framing a query. Okay, well, so for example, if you want to find citations or papers on the effect of heat or humidity on multiple sclerosis. Okay, so what you would do is that you would create a query in parentheses. This parenthesis would be, executed first. Okay, so in parentheses, you would give the term heat or humidity. This would eventually first find out all the article which contains either heat or humidity, and then it would be ended with multiple sclerosis. Okay, so in this way, by using this parentheses, you can nest out your queries. Okay. Well, so for example, next, if you want to find out the citations about arthritis, but it should not contain the publication type letter. Okay, so you don't want to include the letters that were written to those editors. On contrary, you would like to have other type of articles to be reported. In such case, you can, you can use the query like arthritis, but not the letter in publication type as a tag. Okay, so these are an efficient way by which you can perform, smartly. You can search out your databases. Okay, that would significantly reduce the junk that you usually end up while searching. Okay, so now you might have wondered how this multiple sclerosis wouldn't be identified as multiple and sclerosis as a different term. Okay, so in this case, how this vitamin C would be considered as a phrase and not as a separate term, vitamin and C. Why? Because they are differentiated by spaces. Then how do PubMed make sure of those things? How do it identifies terms and phrases separately? तो इसके लिए they use something called as automatic term mapping to identify the concept. Okay, if you have a multi-word queries or multi-word phrases searches in your PubMed, automatic term mapping engine would be first run on those phrases or multi-word queries. Okay, for example, the search for air bladder fistula, PubMed will search air bladder as a phrase and fistula as a term. Okay, so now specifically, if you do not want a automatic term mapping to be active, then you would have to put and in between each and every term. So the query would be air and then bladder and fistula. So this would separate air and bladder. So automatic term mapping is, you can say, an artificial intelligence program that has kind of identified that what two terms are usually used one after another and hence can be used as a phrases. Okay, so this is how it searches. Now, in your PubMed, how the query was translated or interpreted, you can view it in your details portlet display tab. Okay, I will show you how things are to be interpreted in such a way. Okay, so next thing that I wish to talk about is how do you interpret what you have got. Okay, so how do you understand your search result? Okay, the search result are initially displayed in summary format. Okay, in order they were entered in PubMed. That is, last in would be first out. Okay, So by default, 20 citations are displayed per page and remaining are displayed on subsequent page. So you would have to hit that next button in order to see the next subsequent search results. Okay, so now to display the abstract of a journal, you would have to click for each citation so that you can view in more details of that. Okay, so now you should also know that citation don't include the abstract display. There would be something shown over there like no abstract is available if the abstract is not given for that particular citation. Yes, it happens many times such a way कि abstract ही नहीं रहता है. Okay, so this is how your summary search result would look like. You would have a link. You would have a link to your title. Okay. Then title के नीचे रहेगा the list of author. उसके नीचे रहेगा the citations, the journal in which it was published, the year, and the well, say for example, month and date. Then there would be volume, then there would be issue, then there would be, you know, the page numbers. Okay, and you of course also have e-pagination in form of digital object identifiers. Okay, so digital object identifiers are, you know, you can say if you assign a digital object identifier to any electronic entity on the web, it won't change. Okay, so digital object identifier are, you know, like they would make that thing permanent. They would make that electronic object as permanent. Okay, so this is how things work. So you would get results something like this. Okay, well, say for example, if you search by author name, Mishra Marje, by my name for the sake of simplicity, you would get some query result something like this. Okay, so this graph that you see has been recently added in the new version. It was not present in your legacy version. It would give you an idea about what is the frequency of this author's contribution in the given course of time. Okay, so as you can see, uh, you have different options available over here that would allow you to do different things, right? So we'll say, for example, if you hit on this save button, so this would allow you to save the selected citations or selected set of entries that you have opted. Okay, so now you can either save all the results present on this particular page or all the results that it has obtained throughout the, you know, subsequent pages, or you can say you can only save the selection. Okay, now the thing is that you can select using these check boxes. Okay, I want to only select save only these two citations, then in such case you can use this selection. And when you create this when you hit this create file, whatever you have selected would be saved in a text file so that you can view that thing later. Okay, similarly you can also select the format. Either you can save everything in text format, or you can save only pubmed IDs, or you can also save the abstract in form of text so that there would be no links over there, or you can save everything in a comma separated value if you are planning to do some analysis in Excel, or say for example in any spreadsheet application, right? So this is how you save the result. Of course you can also email the results. Okay, email करने के लिए all you need to do is to put your email over here. Then you would select you would have to make a selection. Okay, selection is the same as the save option that I have already mentioned before. Okay, and you can also select the format in which you want to send your result. Okay, whether you want to send only the summary, or you can send the abstract with links, or you can only send abstract with text. Okay, so this is how you can email the citations to your guides or to your supervisor if you wish. Okay, the next tab over here is send to option. Okay, if you click on this send to, you would be you would be kind of given access to these four menus. If you click on this clipboard, whatever you have searched, would be saved temporarily on the NCBI's memory or the search engine's memory. Okay, then you can send these results to my bibliography, or NCBI's my collection is also one of the option that you can save your query results indefinitely. Okay, so there is difference between saving your results on clipboard and saving your results in collection. Okay, mind you, if you send your results to this clipboard, that would mean that the results of your search would be saved on the NCBI server for only 8 hours. After 8 hours of inactivity, the results would be deleted. Okay, but now if you save it in NCBI's my collection, it would be saved indefinitely. Okay, you can fetch those results anytime you wish, but to use this NCBI's my collection utility, you would have to have say you would have to have an account that is needed to be created. Okay, then one more handy thing that these guys allow is that saving your results in citation manager format. Okay, now there are different software that are used by the scientific people to manage their references.
Hello, sir.
Yes.
Sir, Sir Sangeeta ma'am also created the Zoom meet now. So they are logging.
Okay, so what time do we have? It's 12:32. Okay, then we would continue our discussion in next lecture, right?
Yes, sir.
Yes.
Thank you.
Okay, 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 okay.
Thank you, sir.